When interacting with a large language model, we usually provide an instruction and receive an output. Thanks to their text to text format, large language models are capable of solving a wide variety of tasks using a single model. Such a capability was originally demonstrated via zero and few short learning with models like GPT-2 and GPT-3. When fine-tuned to align with human preferences and instructions, LLMs become even more powerful, enabling popular generative applications like coding assistants, information-seeking dialogue agents, and chat-based search tools. These applications have rapidly propelled LLMs to prominence in both research communities and mainstream culture. At a high level, LLMs operate by taking a prompt as an input. The prompt is your text input that you pass to the model. Your prompt might look like an instruction, and maybe you add some examples. Then, you send this text to the model to get it to take on the behavior that you want. So, what is prompt engineering? Prompt engineering basically deals with the study of how to communicate with LLMs to steer its behavior for desired outcomes without updating the model weights. Given the current hype around LLMs, we might wonder what makes them so powerful. And there isn't a single answer, but a few key strengths stand out. First, their massive scale, with models reaching billions of parameters, and the enormous pre training data, sometimes involving trillions of tokens, play a significant role. Human feedback also helps align these models with human preferences. However, one of the major strengths of LLMs is their versatile text to text format. Their expertise in next token prediction allows them to solve a wide range of tasks by effectively tuning and utilizing this ability. Such a unified approach can be used for translation, summarization, question answering, classification, and much more. The wording and structure of the prompt provided to the LLM can significantly impact the model's accuracy. In other words, prompt engineering is a huge deal. There are a variety of options for how a prompt can be created. However, most prompts are comprised of the same few components. First is the instruction, which is a clear directive or command telling the model what to do. It defines the goal of the prompt, like summarize this article, or in this case, translate the sentence from French to English. Next is the input data, which is the raw text or information given to the model to process. This could be a simple query, piece of text, or a dataset that the model will use to generate its response. Exemplars are provided in the prompt to guide the model on how to respond. These can be specific examples or few short learning techniques where you show the model sample inputs and expected outputs to steer its performance. Indicators are hints or guiding words embedded in the prompt to signal the desired structure or format of the response. For example, starting with answer or output helps the model understand the format it should follow. Context is the additional background or information provided in the prompt that helps the model understand the situation or topic better. It helps the model generate a more relevant and accurate response by placing the task within a specific scenario or framework. These elements together form a well structured prompt to guide the model's output effectively. Although LLMs have seen a recent explosion due to popular models like ChatGPT, prompting has been around for a while. There are tons of prompting techniques available out there. With the proposal of GPT-2, we saw researchers start to use zero shot learning to solve multiple downstream tasks with a single foundational model. Finally, GPT-3 showed us that language models become really good at few shot learning as they grow in size. In this section, you'll gain a better idea of how zero and few shot learning work, as well as provide details on a few more complex prompting techniques. We will cover the rest of the prompting methods in separate videos. Zero shot prompting means that the prompt used to interact with the model won't contain examples or demonstrations. The zero shot prompt directly instructs the model to perform a task without any additional examples to steer it. Due to the massive amount of pre training data they observe, LLMs are pretty capable of solving tasks in this way. Namely, they can leverage their knowledge base to solve a large number of tasks. Zero shot prompting is one of the most widely used methods in interacting with large language models. Let's look at three questions given to Gemini, a large language model chatbot developed by Google AI. First question: if a person sees a painting in a mirror, does the reflection of the painting show more detail, less detail, or the same amount of detail as the original? And explain why. Gemini first answers the question and then provides an explanation to it. Here's another question. Translate the following sentence into French while preserving its double meaning. The old man, the boat. This is a challenging translation due to ambiguity in French interpretations. Gemini explains that it cannot provide a direct answer and then provides the reason of ambiguity. Now, last example, which is a riddle. Get a wolf, goat, and cabbage across a river one at a time without any being eaten. Gemini provides a complete step by step approach of how this problem can be solved. Zero shot learning was explored extensively by models like GPT-2 and performs well in some cases. However, what should we do if zero shot learning does not solve our task? In many cases, we can drastically improve the performance of an LLM by providing more specific and concrete information. In particular, we can start adding examples of desired output to the prompt, allowing the model to replicate patterns from data seen in the prompt. That's where few shot prompting comes in. Beyond just a task description, we can augment our prompt with high quality input output examples. Few shot prompting attempts to improve LLM performance by providing explicit examples of correct behavior. Few shot learning is incredibly effective, as demonstrated by the breakthrough capabilities of LLMs like GPT-3. However, learning how to properly leverage the few shot learning capabilities of LLMs can be complicated. What examples should we include in the prompt? Is there a correct way to structure the prompt? Do changes to prompt significantly affect the LLM? Most LLMs are sensitive to the manner in which prompt is constructed, making prompt engineering both difficult and important. Exemplar ordering is important, and permuting few shot examples can drastically change LLM performance. Including more few shot examples does not solve this problem. The distribution of labels in the few shot examples matter and should match the actual distribution of data in the wild. Surprisingly, the correctness of labels is not as important. LLMs tend to be biased towards repeating the last of the few short examples. Exemplars that are included in the prompt should be diverse and randomly ordered. In summary, selecting examples that are diverse, randomly ordered, and related to the text example is best. Let's take a look at some questions provided to Gemini. First question. We provide Gemini with some examples. That is, a fish swims in the water as a bird flies in the air. A cat naps on a couch as a dog rests in a bed. And then we ask Gemini to complete the analogy, and Gemini goes ahead and provides us with an answer. Next question. If the pattern is 248, the next number is 16. And if the pattern is 136, the next number is 10. Now, given the pattern 5914, the next number is. Gemini answers the question and provides us with the step by step approach to solve the particular mathematical challenge. And finally, if all roses are flowers and some flowers are red, then some roses are red. If all dogs are animals and some animals are wild, then some dogs are wild. Now, if all A are B and some B are C, then. And Gemini answers our questions and provides an explanation to it. Prior to moving on, I want to address a notable point of confusion. Few shot learning is not fine tuning. Few shot learning presents examples to the LLM inside of the prompt, which can then be used as relevant context for generating the correct output. This process is referred to as in context learning. The model's parameters are not modified by few shot learning. In contrast, fine tuning explicitly trains the model, that is, updates its weights via backpropagation over a chosen dataset. Few shot learning is incredibly powerful but has a notable drawback. Exemplars consume a lot of tokens. Given that the context window of an LLM is limited, we might want to explore prompting methods that do not consume as many tokens. For example, can we textually explain the correct behavior to an LLM? And the short answer is yes. Instruction prompting reduces token consumption by providing written instructions instead of exemplars. making it efficient for large language models with limited context windows. Instruction tuning enhances LLM's ability to follow instructions, improving their alignment with human goals, seen in applications like ChatGPT and coding assistants. Pre-trained LLMs are not good at following instructions out of the box. However, teaching these models how to follow instructions makes them a lot better at accomplishing what the user wants. The first step in creating an LLM is pre-training. However, the model's output is not always interesting and we need to go beyond basic pre-training. There are a couple of different approaches for teaching an LLM how to follow instruction. For example, we can perform instruction tuning or fine tune the mod LLM over examples of dialogues that include instructions. Several notable models adopt this approach, such as Llama and its variants, all the FLAN models, OptIML, and more. Alternatively, you could use a three-step approach comprised of supervised fine tuning and reinforcement learning from human feedback, all of which we are going to cover in separate videos. If you have access to an LLM that has been trained to follow instructions, we can accomplish a lot by prompting the model with useful and informative instructions. Here are some key tips and ideas for using instruction prompting. Just like the rest of the prompt, the instruction should be specific and detailed. We should avoid telling the LLM to not do something in the prompt, rather, we should focus on telling the LLM what to do. Using an input structure with indicators that clearly identify the instruction within the prompt is always helpful. Another interesting prompting technique that is tangentially related to instruction prompting is role prompting, which assigns a role or persona to the model. This role is assigned within the prompt via textual snippets, such as you are a famous and brilliant mathematician, you're a doctor, or you're an expert lawyer. Providing a role to LLM can actually improve performance. When assigning a role to the AI, we are giving it some context. This context helps the AI understand the question better. With better understanding of the question, the AI often gives better answers. Prompting LLMs with instructions is an incredibly powerful tool that we can use for a variety of applications. Prompt engineering with large language models such as Gemini or ChatGPT can help you be more productive. With the right prompts, you can have the model summarize, generate, and review content. There are few generally accepted principles for prompt engineering that are always helpful to keep in mind. Tip number one, always start simple. Start with a simple prompt, then slowly modify the prompt while tracking empirical results. For example, explain climate change in 2 sentences suitable for a 10-year-old. Tip number two, always be direct. If we want the LLM to match a specific style or format, we should state this clearly and directly. For example, summarize this article in bullet points with 3 key takeaways. Tip number three, be as specific as possible. Always be clear and precise so the model can understand your request. For example, write a 150-word summary of this research paper highlighting the main contribution, methodology, and results. And finally, tip number four, exemplars are always powerful. If describing what we want is difficult, it might be useful to provide concrete examples of correct output. For example, you can provide an example input output and then give another question and ask it to provide a similar response. Peak productivity starts with a strong prompt, and like Sam Altman once said, writing a really great prompt for a chatbot persona is an amazingly high leverage skill and an early example of programming in a little bit of natural language. Thanks for watching. Really appreciate you sticking around till the end. If you enjoyed the video, don't forget to like, subscribe, and tap the bell icon to stay updated. Drop your thoughts or questions in the comments below, and I'll see you in the next video. Have a good one.